Okay, cool. Hi, everyone. Welcome to the Carpenter Working Group for September 26th. First thing we can get started with is uh project updates. First thing we want to
Hey,
go.
Daniel, do you want to share your screen?
Yes, let me share my screen. Hello? Oh, let me try. Okay. Um, actually, I think I should be able to now. Let's see. Can everyone see my screen now?
Yep.
Okay. Cool. So let's get started with the project updates. First thing is that at least for the Karpenter provider, or for the for the AWS provider, we'll be releasing a few patch releases. I've added a few notable issues, a few bugs that have been reported and that we're planning on making a set of patch releases for versions 0.33 all the way through.
Emmanuel, I think your connection is, if you can hear me, your connection is not too stable, at least for me.
Yeah, he's frozen on our side as well.
Okay.
The Kubernetes SIG. So I think the provider should now be available. So if anybody's
Oh,
interested.
hey, Emmanuel, your video was frozen for a while. We actually didn't hear you for about a minute.
Oh, really?
Yeah.
Okay. My bad.
You could try
Uh,
the video off if that helps.
yeah, let me try that. Okay, I wonder why that's happening. Okay, sorry. Let's try that again then. Wanted to quickly give, not sure how much everyone heard, but let's just wanted to give a quick update on for the AWS provider. We'll be doing a few patch releases. I've linked some notable issues that have been reported based off of the most recent releases. So if you are interested in those, please feel free to take a look. And if you're waiting for those releases, it should be soon. We're just working out the.
Oh no.
We want to hand off if he's having network issues. Maybe.
Can you guys hear me?
No, brother. No.
It's just okay. Maybe somebody else may have to take over. I'm still in the office. I'm surprised why this is happening now. I'm at the office, so
Yeah, all the RTO, I think maybe. New load on the network. No.
okay. Okay. How much? Okay, I will go all. I'll start with the second update. The Carpenter cluster, the cluster API provider. Seems like we have a new the cluster API provider has been donated at least to Kubernetes 6. So if anybody's interested, feel free to go uh take a look. But yeah. So let's move on to the RFCs.
Hey, Jason, do you want to take over? I think you might have internet issues again.
Yeah, no, I can go ahead and take over. I'm on the same network though, so we will see how that goes. Yeah, let me just get everything oriented. Manuel, did you hear that?
Barely.
I can go ahead and try and take over.
Please, yeah, that sounds good.
So yeah, just give me a moment to get everything on up. Okay. My screen sharing, everything working?
Yep.
Okay, so all right. I guess where we left off was updates on the Karpenter provider cluster API. Are you here? I don't see. Don't see Omiko here. So, oh, I might not be able to attend the meeting today. So, okay. Yeah, I mean, this was news to me when I saw it in the working group, but it looks like the project's at a state now where it is, they've got a Kubernetes SIGs repo for it. So that's super exciting. If anyone else has anything to say on it, any knowledge they want to share, that'd be great. But I'm not totally in the loop on this. So, but it is super exciting to see. But if not, we can probably go ahead and move on. So, okay, moving on to RFCs. Unless there were any other project updates, give a second, then move on. Okay, so RFCs, we've got a proposal for discovering VM memory overhead percent. So best to start looking at the issue, pull request, both. Okay, so all right. I think it's Isaac. Do you want to talk about this? I think I saw you were here.
Yeah, I'd love to. If you go back, not this PR, but the other one above this one, feature discover instance type capacity memory overhead. But yeah, like it looks like there was a few old PRs that I found for this somewhere in draft, some or at least one still open. But it basically comes down to the way that VM memory overhead works with Karpenter is just a raw global percentage, and by default 7.5%. And that could lead to some challenges if you're running a cluster with a variety of instance types. So let's say you have a huge one and a small one. That global value isn't necessarily ideal. And what that value does is it just assumes a certain amount of memory is going to be reserved for like the hypervisor or the underlying OS. Basically, just the additional overhead that isn't returned by the described instance types API. And yeah, like that's the rough overview. And so like where we might see problems with that is if I'm a user and I want to achieve, say, like 99 or 100% utilization, if I spin up a pod that should be getting a certain instance type size, Karpenter would by default launch a larger node to account for that. Or on the flip side, if I tune that VM memory overhead value really far down, that might work for that single pod running on, like, let's say a large node, but then for some of the smaller workloads, that might run into issues where Karpenter will spin up a node that actually can't run that workload. So the GitHub issue sort of talks about like how Cluster Autoscaler deals with this by sort of tracking after a node gets launched. And then that's sort of what was proposed in the issue, and sort of what this PR does is it sets up a new controller that once a node becomes registered with Karpenter, it looks at its capacity, and then it stores a cache for that that lasts for 36 hours based on the node class AMIs plus the instance type. So what that means is like whenever Karpenter calls the instance type provider to get a list of instance types, for each one, it'll like if that cache value exists, it will pull from that cached overhead value rather than the VM memory overhead percent. And if a cache value doesn't exist, it just falls back to the existing logic of VM memory overhead percent. So still a preference for the safe, or basically always preferring the safest route of launching an instance. So like even if it's not ideal that we reserve a little bit too much, we can at least guarantee that in, if not all, 99% of use cases that a node will be able to get launched without that constant loop. And for users who maybe want to accept that risk, they can still turn that VM memory overhead percent down. I'd love to discuss if this is a reasonable approach, or if anyone else has given this some thought and maybe wants us to go a different direction.
Yeah, I think Gavin had mentioned, maybe it looks like Nick's already responding, but about like the difference between node overlay, why we might want this over node overlay. I don't, Gavin, did you want to go?
Yeah, I guess
Like
that
Garpin?
makes sense. That is different. One question I have is like, if you pick, are you picking a random node to choose as the overhead for the rest of the nodes that are in similar, like a similar size, a similar instance type?
Not necessarily. So what this will do is it looks at a given node, and it checks that it checks the node class hash to make sure that like it's part of the most recent. Otherwise, it's quote unquote like an older node that we don't necessarily care about caching that value for. And then after that, we also, when we store the memory overhead value, the cache key is based on the node class status AMIs plus the instance type name. So
Right.
does that make, or sorry, did you have a question there?
Sorry, yeah, I guess my question's not that. It's more like, do you just pick the first one of that kind and store in the cache? If that makes sense. Like the first time I saw M5X large on AL2, whatever, of this node class, am I saving that right away into the cache, or am I sampling? If that makes sense.
So the first time that you see that instance, you will store it, and that's what will be referenced until that node class gets, or until the AMIs for that node class gets updated. But then there's also the controller here. I think I'm resyncing every 12 hours. But then if there is another instance type from that same node class that gets launched on the same instance type, so let's say the second N5X large, then we'll basically store that new value if it's changed, or I mean, effectively just refresh the cache, because I mean, in theory, that value, it's likely to be the exact same every time until the AMI changes or AWS hardware changes for
I see.
yeah.
I guess one concern I have here is that what we have seen in our pool of nodes is that the hypervisor overhead varies even within the same instance type. Maybe I need to go back and see. I don't know if it varies a lot. That's why I'm asking, are we sampling? Because maybe you have better data on this on your internal to EC2, but like, I think it varies that value, that overhead. I'm just afraid that the first one that comes up is optimistically taking a little bit less memory than other instances type, in which case now you are assuming incorrectly that the overhead is much lower than it needs to be. Like ideally, the overhead's always higher. So like if you see an instance that come up with higher overhead, you should like override the cache maybe, I don't know. But maybe you know better from your side what that number, how much it fluctuates, but at least we've seen it fluctuate. I just don't know how much off the top of my head.
Okay, I hadn't seen or tracked that yet, but I'm only running this in a small test cluster, so yeah, that wasn't something I was aware or tested of, but that's a really good point. So thank you. So I guess in that scenario, then would you prefer basically just checking when we are storing the cache value that we're always updating it with whatever the highest value is. And I guess, do you have any other suggestions to maybe deal with the variance?
I guess I don't know. I need to double check, but like maybe you can chat with EZ2 or whatever, but then I don't know how much it varies off the top of my head. I know it varies. I guess keeping track of the highs would be great just because that would be the safest option. Beyond that, like, yeah, I think that was the only suggestion I was thinking that might matter. Yeah.
Okay, if maybe I can reach out to like my AWS reps to get an answer from the AWS team, but if there is like a rough estimate of how much variance there could be, would it be acceptable to then just add that slight buffer, or maybe you guys have another preference for what that buffer looks like?
Yeah, I guess what we do on our side is we don't actually know the variance. We just in our population we've seen like I think like up to 5% of the memory consumed by the hypervisor, and we just hard code 5% and move and go from there. I don't think we've seen higher than 5%, if I remember correctly, but that maybe it's like a over estimate. I don't actually know. We haven't rechecked, but then at least that's what we do. Like, oh, we saw the 5% and we just hard cut that across all instance type. We didn't bother varying the overhead between instance types because we didn't actually spend that much time into figuring that out. We just saw 5% is the highest we've seen, and we just cut it there and then moved on. But you don't have to take such a drastic like hard cut approach if you have better data or better information.
Okay. And just to be clear, you're saying that you were seeing variance between the same, or so the same instance type, the same AMI, and you were still seeing variance between the hypervisor?
I think so. I need to double check on that, but then we were seeing I don't know the variance is like that high between instance types. Oh, wait, sorry, within the same instance type. I don't remember that number. I just see I do see variance across instance type, obviously. But I just don't know how much fluctuations within the same instance type.
Okay.
Yeah.
Okay, yeah, that's some data that I can get more data on that today. And yeah, like just because like to maybe reiterate the use case, like I have a few workloads that just use a ton of resources, so they are going to use a larger instance type, and being able to cut it like to 5, or in our case, I've cut it down to 3.25%. That tends to work pretty well. But then we still might have issues with some of the smaller workloads not having enough reserved, or yeah, not having enough reserved on those nodes. So just looking for a way to come up with something that's a little bit more flexible, rather than a global value. But
Yeah.
if there is a ton of variance between instance types, that would be a problem here. But okay, I'll get some data on that today. If let's say that it's a small amount, just for the sake of discussion, would whenever I'm updating the cache values, if we just make sure that we're checking that whatever the highest value always wins, would that be acceptable to move this a little bit forward?
Well, I think we want it the opposite direction, right? The lowest value to ensure that Karpenter isn't overestimating the resources on a node.
No, I think higher.
Yeah.
Yeah, like depending how you look, yeah, like essentially cut off the bigger chunk of memory that we've seen.
Right. Yeah. Yeah. So sorry if I added confusion, but yeah, that's what I was saying. So like when we track the overhead, I'm saying make sure that the higher amount of overhead that we've tracked is kept in
Yes.
cache rather than the smaller.
Yep. Okay, same page. Yeah, I mean, that definitely makes sense to me. I think from what we've discussed a little bit, like the only other concern we really had was the potential variance even within single AMI, single instance type. If we have an effective way to track that variance, it's probably pretty reasonable.
Okay. Do any of you happen to have? I'm gonna go ahead and run some tests myself. Like I can do it in, I don't know, at least 3 or 4 regions and different AZs to get some tests going. But is there any good resource or like maybe another place that I should check to maybe get a straight answer on that?
From what I've seen, from what we dealt with internally, like when we ran to this issue, there was like no official docs or anything. We only found out more information talking directly to AWS. So I don't know if that changed, but that's at least what we ran into.
Okay. Okay. Yeah. I'll try to go that route too then. Cool. Thank you.
Yeah, thanks. And then, yeah, if you do get those findings, if you would be able to update your PR with them, that would be fantastic.
Will do. Cool. Yeah. I think that's all I had. Yeah. Thanks for the time.
All right, cool. Thank you. Okay, so I think that was all we had for RFCs. So, oh, okay, just the AI. All right, so heading on to community questions, starting with issue 746, dynamic taints based on tolerations. Whoever added this, if you want to take it away.
That's me. I know this is 2022. I revived this ish. Well, I think it was never closed, but then if you go to the bottom, I mentioned where this kind of ended off, which was a situation of sort of non-deterministic behavior and a question around that. I thought it wasn't really a non-deterministic behavior. I just want to bring this back because there is some need for, at least for us, to both isolate nodes and also target nodes, and the ability to dynamically taint, similar to how we dynamically label nodes, would be very helpful here. I think the discussion ended with a situation where if a pod comes up, depending on order of when pods come up, and if they have a specific toleration, the nodes created would differ. But I guess to me that wasn't not necessarily non-deterministic because the situation of the cluster differed between the two situations, hence the different outcomes. I don't know if this is still something other people are looking for, but at least for myself, unless there's another way to do this where taints can be created dynamically through toleration, or some other way, that'd be great. But yeah, I feel like this is still a thing that a way to isolate things without creating many node pools would be great. Yeah, I think Jonathan was last interaction with, I forgot who on this, but then yeah.
Yeah, I mean, I think the use case definitely makes sense. I don't know. I haven't taken a look at this to really understand the non-deterministic aspect of it. Jonathan, do you have anything?
Yeah, man, I think this was like one of the first issues I looked at when I like started on this project. So I think my thinking on this has maybe changed over time. But man, I'd have to refresh because yeah, this has been open for a while.
Yeah, I no rush on like getting this looked at whatever, but I just want to revive and see and bring this up and see where it goes.
Yeah, I do wonder, to Jeremy's point in the chat, if there's a way to achieve this with like anti-affinity rather than something on the Karpenter level. Especially with something like mismatched label keys that was added recently.
Yeah, I guess one thing is it's hard for us to do anti-affinity because how big our cluster is. Like pod to pod anti-affinity tends to bring down the performance of scheduler if your cluster is relatively big. So we can't really do anti-affinity between pods. Maybe we can do it with I guess the one thing there is that anti-affinity and pods and node selector works if then you control the entire cluster and enforce that exists on everyone, or else some pod can come up without any of the rules apply and they can land on things because attain is the only way to block things from landing on a specific node, whereas anti-affinity and all those pieces they don't block things out. You simply it's a way to select into a node. So unless you control the entire cluster and how all the pods are created, those things are not enough to prevent things from landing onto nodes, if that makes sense.
Yeah, that makes sense. So it's probably technically possible, but you may need to set
Right.
up like some admission policies and it could have
Right.
some additional performance impact. So
Yeah.
I think that definitely makes sense and makes sense why we should consider it for Karpenter. Yeah, I don't know if any of us have looked at it recently enough to really understand the trade-offs at the moment.
Yeah, no worries. I didn't think so. I just want to bring it up, but yeah.
Yeah. Okay. I think, yeah, definitely something we'll have to take a look at again. So thanks for raising it.
Thanks.
Okay. So moving on to, okay, this one's the TLS handshake error from API server. Is whoever added this here?
Hi, yeah, I think Mohammed added this one. Asked if I could speak to it. I don't really have anything to add beyond this issue. It's still popping up for us, where the conversion API is getting TLS errors just with the default configuration. This just seems like a bug, but yeah, I don't really have anything beyond that here.
I think, Jonathan, do you know, is this the same issue as the spurious TLS error that we have a fix for?
There was a different issue that was like HTTP being sent over HTTPS. This one, I think, man, I think this one was open, like last time we had to, we went through this cycle of like candidate webhooks and then dropping webhooks and we had to bring them back for conversion. So I think there's an old issue beyond this one that has the same, like, hey, there's TLS handshake errors happening. And I think we tried to track it down and never were able to figure it out. And I think we basically resolved it was a non-issue, but to find that, I honestly don't know. Are you seeing impact when that you get those errors, or is it just, we're seeing
Yeah,
these
we
errors?
haven't really been seeing any blocking impact from this. It's just a bunch of errors polluting the logs.
Right.
I assume it's not working, but
You should be seeing other like impactful errors if like failure to list or get node claims, failure to sync caches, if it's actually blocking the conversion webhook, at least if I understand correctly.
If this is the same one though. There's this issue, which is quite old. And I thought there was like, I thought that basically I think I did a little bit of looking at this. Yeah, okay, yeah, I think it's the same. So that links to this one, which is 718. And the resolution was it's an issue with upstream Kubernetes and Go itself, like the Go standard library, if I remember correctly. And I think that's where it ended. Because we closed this when we said, okay, great, no more webhooks. And then we're back. So I'd have to look again at this, but I believe the answer is it's not an issue. It's an issue with the Go standard library. And the way that it handles connection pools. But I need to read up again.
Okay, I mean that makes sense. We're not seeing any other errors and everything, so yeah,
Yeah.
just log errors.
Okay, yeah, so I think, yeah, if you do end up running into any impacts that you think's correlated with this, definitely updating the issue. I think, but yeah, I don't know if there's much actionable here at the moment, given we're also dropping webhooks at 1.1. So. All right. Unless there's anything else there, I think we can move on to the next issue, right? Okay, whoever posted this, if you want to take it away.
Yeah, another one for me to talk about. Yeah, so it looks like we have some hard-coded values for the node claim reconciler. The values are also really high. It allows we have bucket size of 100 and 10 additional node claims a second. So in our recent scale testing that we were spinning up, our repeatable scale tests that we just started with Karpenter, when we try and scale up to 2,500 nodes, we instantly start DOSing the EC2 APIs or getting throttled, whatever you want to call it. So it'd be nice if we had these as tunable values.
Mhm. Mhm.
Which API? I think it was one of the fleet ones. I'd have to double check.
Okay, so probably create fleet.
Yeah, it was when we were trying to start an instance. We were
Yeah, it should be
getting
good.
errors.
We had a similar issue too, except our solution is to ask AWS to increase our rate limit, but I agree that it would be great if it's tunable at least. I don't know if you can actually on the AWS API, sorry, AWS SDK client to actually change the QPS per call, but you may be able to set the QPS across the client. I don't actually know off the top of my head.
Yeah, I mean, we were just trying to change like the node claim thing, like limits. I think we're testing it now with initial bucket size of 10 and then 5 node claims per second. Like, and it still scales up to 2,500 nodes in just over 15 minutes. So we figured that was high enough and errors are starting to go away. So yeah, just having it tunable would be nice.
So part of it too, though, is that the rate limiting here isn't going to actually affect the initial calls. This basically only affects as items are requeued back into the controller. So like upon an error or upon us like retrying in a non-errorful way. So you could still, if you had a, like 2,500 node claims created right off the bat, they would still get reconciled without this rate limit necessarily affecting them. Which is just an interesting quirk of controller runtime rate limiting.
Yeah.
So you would still see, I don't know if necessarily these are the things you want to tune. And that's where Yeah, I think, so there is client-side rate limiting for the AWS SDK. But I do think, and someone can correct me if I'm wrong, I do think it is global rate limiting only. I don't think we could specifically set a rate limit on our create fleet bucket.
Yeah, and the limiting's also not per IAM role or anything like that either. So, we have multiple clusters running Karpenter, all hitting the EC2 APIs. You hit
Yeah, so
these issues.
I guess with this, are you really looking to have it back off more aggressively once you start hitting rate limit, like once you start receiving rate limiting errors from the APIs rather than actually rate limiting the calls themselves, or like rate limiting the initial calls? I don't know if that
Yeah,
makes
I mean, both would be good, right? Like if we could have the bucket rate limiter automatically or instantly engaged, that would be awesome. But yeah, I mean, it's good enough if it just backs off right away. Because what we were noticing is that we just had to wait quite a while because the bucket rate limiter was actually too fast for the EC2 API to quote unquote recover. It would take quite a while because we'd keep hammering it with requests until the rate limiters were waiting long enough.
right. Yeah, so doing it here though, you also don't have, because I know you had mentioned like if you're doing it on the SDK side, it's only for this Karpenter client. It's really the same case here.
Yeah, no, definitely.
Yeah.
It sounds like at least this rate limiter, right? Like it sounds like if the underlying call to AWS is getting throttled, there needs to be back pressure on this retry on the controller such that it doesn't continue to retry at the same rate, if that makes sense. Because you're just running against the wall and you continue to run the same speed against the wall. So like there needs some kind of back pressure when the AP, like the SDK, EC2 SDK or something is not able to do at the rate that this thing is going at, and push back and say you should slow down even more than whatever this rate limiting is going to.
Yeah. I guess this is more of a question for others. Has surfacing, I'm not aware of like historical context necessarily. Have we considered surfacing these types of rate limit controls in the past? Because I know we have like configurable rate limits for like the Kubernetes client. But what about AWS or individual controllers?
Yeah, we haven't. Yeah, what makes this complicated, we've actually had a few discussions about this for other things, is like there's multiple rate limiting mechanisms at play here. And like reasoning about the combination of them is kind of is complicated. And on top of the fact that like what Jason just called out, like we don't rate limit on the front end, which I think is fine because it'll fire once and then back off, and then you'll get the actual rate limiting at that point. But like the AWS SDK, at least the SKV1 has a certain form of rate limiting, and that rate limiting applies to the retry. And then SKV2 has a different form of rate limiting, and there's also rate limiting on, well, there's rate limiting in a way that does like circuit breaking, so it won't retry, but it still fires the first request, but control runtime is still going to retry, and that's going to rate limit. So like there's the only concern I would have with making it making a rate limiting configuration here is like making it like parsable to somebody. Like if we can't even reason about how things are going to rate limit given our back off logic today, like I think the first solve here is like make our back off logic more understandable to ourselves as developers so that we can even like start to even think about what a user rate limiting would even look like. Because as it stands today, there's not really a good way to like recommend to anybody, I think, what this should look like, because like we hardly understand. I mean, we do understand to some degree how this works, but like I think the interactions are a little bit complicated as it stands today.
Yeah, it's hard to understand. Like you can't just tune a value and know exactly what's going to happen. You almost have to simulate it to verify it reacts with the other rate limiting mechanisms in the way you expect.
Yeah, I mean that's why we want this change, right? Since these aren't exposed, uh, the way we have to make these changes is within our fork, we have to edit the code, build a new image, test it, versus just changing environment variable.
Mhm.
You have to do this with other, like any other components you install in your cluster that may call AWS APIs, or do you have other things that are as aggressive?
We haven't run into anything else. Yeah, the only issue with this that we ran into our other scale test was basically Karpenter would go and launch a few hundred node claims. For some reason, it wouldn't launch node claims for every pending pod, but that didn't really matter because it was fast enough. And then you get, a few hundred nodes into your first, or you get your first 1,000 or so nodes would come up, and then suddenly it would just completely stall out. And then with these rates, it would take 15, 20 minutes to uninstall. And then it would launch another 500 nodes and then it would stall again. And then there's other issues with launching that many nodes at once. They start all requesting metadata, DNS queries, everything all at once. So you get quite the thundering herd, which we just thought these values are way too high.
So
And having them tunable would make it a lot easier to figure out what good values are.
yeah, I guess from your perspective, like you're still gonna have this, like the quote unquote slowness. If you reduce the values, you'll just have less API calls. Is that what you're thinking?
Yeah, we're thinking less API calls, because we were thinking it takes so long to uninstall, right? That the API when we keep hitting it,
Mhm.
for the full, for a node to get provisioned. That yeah, just going slower to start with makes it a lot more easy or a lot faster overall.
Were you seeing that to be true? Like, I guess I'm skeptical that that would be true.
Yeah. So we could launch our scale test pods if we start adding sleep statements like sleep 10 in between each,
Mhm.
like estimated every 50 nodes that are coming up, we could add extra sleep statements and it would
Mhm.
keep going. That the stall time was really huge, like 15-20 minutes where we're just no new nodes launch.
I would say I saw the same thing. We were doing load testing. We were scaling up to 2,500 node and 1,500 node in one shot, and it also just hangs out and do nothing. I suspect, like, I didn't take that deep look into it, but I'm pretty sure it's like internal throttling. I just couldn't figure out what is throttling. And yeah, like Jeremy was saying, like there's no way to tweak it short of forking the code. I don't know what to tweak, but there's like not much you can do when you're staring at a cluster that's stuck trying to spin up nodes, and doesn't seem like anything's progressing. Yeah.
So do you know at that point, were node claims created? Like, do you know, were you actually stalled on the instance launches, or could it have been, say, stalled in like the scheduling loop if you had complex scheduling constraints that were taking a while to compute?
For our use case, there was no complex scheduling. I was seeing node claims stop being created, and but then new node is still waiting for new nodes to come up to be registered and tied to a node claim. But no, like it happens in steps. I'm not completely sure. I haven't looked at it that deeply. We're gonna retry the load test sometime later, but I think similar journeys, like we see like batches of nodes being created and then stops. Oh, sorry, batches of node claim being created and then it stops, and then batches being created and stops. It's just, I couldn't tell what was stalling or batching or whatever's happening, but yeah, or something getting saturated. I don't know what.
Yeah, because I think like in the example of this controller, for example, backing off here wouldn't necessarily be the right solution because this is after node claims are already created. We're reconciling on those node claims to actually launch the instance associated with them, register them, etc. And that's where I definitely understand the problem. I think just both me and Jonathan a little bit skeptical that surfacing these rate limits specifically is the correct solution.
Yeah,
And
I mean,
if we were
frankly,
to-
I think the right solve is make it faster. I mean, honestly, right? Like the right solve is not to like get around the rate limits. I think the right solve is to figure out how we can make it so that we can launch more aggressively.
I guess, sorry, don't mean to hijack, but like, it would be great if we can, I don't know if, I didn't know you guys were using AWS SDK v1, but like, if you can expose the QPS for the AWS client, that'd be great too, because we know our account has like higher rate limits, so we can mess around with higher QPS than whatever default is, but that I don't think is exposed right now. Sorry, that's all. I don't want to hijack.
Yeah, I mean, I don't really have much more to add to it. I mean, yeah, these could be the wrong rate limits to set. But at the same time, being able to set them here at least gives us a way to see if that helps us.
Yeah,
I don't know,
I think. Oh, sorry.
I don't know. I just think of it like I've worked on a few like enterprise Java projects, right, where every single setting is tunable, and they expose like 1,000 settings, and it's like it's kind of nice when you actually need to go dig into something, and you're like, oh, I can just set all these values to whatever, play around with them.
Yeah, there's this like balance we have to strike, unfortunately, between like, I mean, you get this, I know. It's like the balance you strike between like your people that are really deep into the details here, and then those that are just like trying to approach it fresh and understand like what's the right way to configure this. And I think the like being able to set the like certain configuration settings makes sense only in the context of like there's a good reason to set one value or the other, and it's like super clear about like why you would set one or the other. And to Garvin's point about like I have higher limits, therefore I want my like client to have higher QPS. I think that's the same reason we surface the Kubernetes API QPS today is like you may support higher QPS in your API server because you're running like a bigger API server in the back end. And so you can handle a higher QPS than what we give you in the client. Like we would constrain on the client side. I think we kind of need to, yeah, I still am of the opinion that like we should just be right on these things and be aggressive, like be faster and be right about what our rate limits are. And then out of that can arise like very specific, like, okay. And maybe that means we reduce the rate limit today for now because it's wrong. It's too high or something like that. But I feel like releasing tunable settings here too early before we really understand like why you'd set one or the other and like what the good reasons are is kind of I think we're pretty cautious about that because once we release it, we can't really go back on it, and then we kind of end up in a state where there's too many things to configure and it's really hard to reason about what you set and why you wouldn't set it.
I mean, yeah and no at the same time, right? Like if you go into back to the Java land, right, you have all those experimental flags or GC flags, and the advice from, the project is unless you really know what you're doing, don't touch these. Right? It's like if you're doing kernel tuning for your app, it's don't touch that. Just use the default. But certain people want the setting exposed.
Do you have an issue for this? It'd be great to trace this down.
Yeah.
1717.
Okay, it's in the dog, sorry.
Yep. Yeah, it should be the last one, community questions. Yeah, I think it would be at the very least interesting to see like what your results are tuning these values. Like how it actually, like some concrete data on how this makes a difference in like node startup time in a scale test.
Yeah, definitely. Um,
Because I think that's where my main skepticism is coming from is, um, especially since is only rate limiting errors, not initial calls. I'm surprised that this makes a tangible difference.
yeah, I didn't realize it doesn't rate limit all calls. I thought it
That
did,
is
but I didn't dive too deep.
that is my understanding from the last time I read through the controller runtime reconciler code. But it's been a moment since I've dove deep into it, so I could be proven. I'm welcome to be proven wrong, but that's my understanding.
I think Jason, now that you mention it, yeah, I think the reconcile requests are requeued on error.
Mhm.
So yeah, makes sense. So we may, yeah, I think this needs a bit more investigation on our side, and see,
Mhm.
yeah, the results as mentioned. We upload the results here and see, what difference would it make? Does it, yeah, even make sense to change this then?
Yeah. All right, cool. Unless there's anything else on that topic, I don't think we have anything else in the doc. So unless anyone has any last minute additions, I think we can probably end a few minutes early. Okay, cool. Well, thank you all for coming. See you in a couple weeks at the next meeting. Thank you.
Thank you.
Thank you.